It's simple mathematics. Check it out. I revolve around science.
What are we talking about here?
All right, I'm just going to review what we've talked about in class in terms of addition and subtraction. I'm making new videos because I didn't like the ones that I had on YouTube, so I'm going to post these ones to the website. Well, you're obviously watching it from the website. So anyways, I'm just going to review the modeling and then what we do mathematically. Okay, so we have 2/3 and 1/2. First thing I'm going to show you is the concept that we need to think about in terms of addition, and that is we can't addition and subtraction. We cannot put pieces together or take pieces away if we don't have the same size pieces. So I have one whole object that I've drawn here, and I am going to separate this one out into thirds. So there I've just cut up the whole into 3 equal groups. I'm going to then shade in how much of the fraction I have. So you can see I have 1/3 and 2/3 in the first fraction, and then I have half in the other fraction. Okay? Now I'm trying to make these halves as best as I can, and I'm trying to draw the model as accurate as I can, but remember I'm not using a ruler and I'm not measuring them out. But these look pretty close, and that looks like pretty close to half. Okay, so this says I need to put 2/3 with 1/2, but you can clearly see that these two objects are not the same size. This is not the same size as this, so how would I know how much I had unless I make them the same size? Now, Mathies, or the math language, tells me that I need to find common denominators. Well, when I model, that's exactly what I'm doing. So I'm going to go ahead and split these thirds in half to make 6, and then I'm going to take these halves, and cut them into thirds, and then I end up with a total of 6 pieces in the fraction of the whole. 6 pieces in the whole, and you can clearly see that I have 1, 2, 3, 4 pieces that are red. Here I have 3 pieces. All right, so now they're the same size pieces roughly, and I can put them together. So I'm going to kind of just, if you thought about it, I'm going to fill in over here. All right, so I can take the 3 that I already have in green and go, okay, there's 1, 2, 3. All right, and it would look like I have 1 left over. So I need to then make a whole new fraction, and I have to take this one and put it there, right? So I end up with that whole. So if we take the math side of it, we end up with 4/6 is equal to 2/3. These are equivalent. Okay, and 1/2 is equal to 3/6. These are equivalent. We haven't done anything to really change them. All we've done is just make them so that we have the same size pieces, or finding a common denominator, and we end up with 7/6. Okay, now as I said in class, you have to look at your final answer and you have to say, is it accurate? Well, I've shown that that is obviously accurate. Is it reduced? Well, I can't really get a number of 6ths out of 7ths, and 7 is a prime number, so it has to be the lowest form. Okay, now we can also turn this into, I can get one group of 6 out of 7. All right, so then I take 7 minus 6 equals 1. That means I have 1 left over. I end up with 1/6, and that would reflect in the answer 1 whole and 1/6 left over. Okay, so that's addition in a nutshell. Notice that I modeled my first fraction as columns, my second fraction as rows. I did common denominators by turning my thirds, I cut them in half, or put half as rows. I turn my half into thirds by doing columns. And then I have equal sized pieces. My new fraction is out of 6ths. Okay, so I end up with 4/6 and 3/6. Together they make 7/6, or 1 and 1/6. Okay, so that's addition. Now we're going to go and show the same thing in subtraction, but this, because they're opposite, I'm not putting together, I am taking away. So it's sort of like I get to eat the amount of the second fraction from the first. Alright, so I'm going to go ahead and model my fraction. It doesn't have to be, you don't have to do columns every time. Alright, I just happen to start that way. So it doesn't matter, you can start with rows or you can start with columns. Alright, so it's there. My lines are getting a little off, but close enough. Alright, so I have to model 3 of those. So I end up with 1, 2, and 3/5. Okay, and then in the next fraction I have thirds, 1, 2. So I'm going to model these red. Alright, alright, 1/3. Okay, so now I cannot take this away from that because I don't know what value it holds because they're not the same size. So I'm going to cut my fifths into thirds and my thirds into fifths. It's going to be tricky. I should have done my fraction a little wider, but that's all right. Yeah, it doesn't look very good, but I know that that's a fraction there. So I have 1, 2, 3, 4, 5 there. So I'm taking essentially 5 away from this value of green. Alright, so I can eat 5 of the green pieces. So I'm going to go ahead and eat, alright, I'm going to eat 1 piece, 2 pieces, 3 pieces, 4 pieces, 5 pieces. Alright, now if I change my pen, I can sort of go, alright, I'm going to eat that piece, and then I'm going to eat that piece, and then I'm going to eat that piece, eat that piece, alright, eat this piece. So we saw, I kind of, alright, I'm eating all of this right here. Alright, so you can see that I've now eaten all of these pieces as best I can. So, as I said before, I was taking away these 5 from these 9. Alright, so in the original fraction I ended up with 9/15. Alright, and then here I'm taking away 5/15. Alright, so you can see that I'm left over with here with four little pieces of green cake, alright, out of 15, alright. Okay, so then I have to look, is this accurate? Well, I've shown that it's accurate, but is it reduced? Well, I know that 4 is an even number, can be divided by 2. I know that 15 can be divided by 3 and 5 and 15, but I don't see any common factors. So therefore, that would be in lowest terms. So we end up with 4/15. Okay? And here we ended up with 7/6. Alright, or 1 and 1/6. Okay? So, just going to show you next what that looks like math. Okay, so now, what did that all look like mathematically? Well, when we made the model, we ended up turning our thirds into halves. All right, which then meant that we cut what we had. The 2/3 became 2 more, so we ended up with 4/6 plus we turned our halves into thirds, which meant that our 1 whole was cut up into 3 equal pieces. Our 1 on top, sorry, not 1 whole, but our 1 on top was cut into 3 equal pieces. So we ended up with 3/6. We put those together, we end up with 7/6. Okay? On the other side, we ended up with turning our fifths into thirds. Our 3 became 3 more. All right, our thirds became fifths, and our 1 got cut up into 5 equal pieces. Therefore, we ended up with 9/15 minus 5/15 which then equaled 4/15. Okay, so that is addition and subtraction in a nutshell.
Check it out.